We good? All right. Sorry, didn't mean to startle everybody there. Thank you all for spending the next hour with us. We use these sessions to kind of give you a sense of what we're hearing across the business in the telco space. By way of introduction, I'm Chivas Nambiar. I run the telco business here at AWS, and partnering with me today is Ishwar Parulkar sitting there, who's the CTO for the business unit. Today we'll cover a little bit of a year in review, the things that we've seen over the last year. We'll talk a little bit about what we call the telco flywheel, and then, as you can imagine, we'll talk about generative AI and modernization. Last year we were up on stage here, and this is what we said, right? And if you think about the things that we said, two of these things actually came pretty close to real. We can see telcos spend a lot of time in the last year in reimagining what the customer experience looks like. And a lot of it was driven by the fact that generative AI as a topic of interest, of applicability to use cases, became real. The one place that we didn't see quite as much traction that we thought we would see is in digitizing industry use cases. We still see operators struggle to find use cases that are scalable, that are deployable in multiple geographies, and we think that over time we still are optimistic about this space, especially as you start to see 5G SA deployments across and it becomes so ubiquitous. We expect to see more there. But it hasn't moved as much as we thought it would in the last year. I will say, though, that in 2024 up to now, there hasn't been a lack of bold bets, though. We see a lot of leaders placing bets around generative AI, placing bets around modernization, network transformation. If you look at examples like SK Telecom, where they went out and built a custom telco model, fine-tuned large language models using their data to improve their customer experience. If you think about Docomo, that's partnered with AWS to go out and build the next generation of 5G core and RAN deployments nationwide. Today, we are announcing actually that Comcast has taken their 5G core and moving that onto AWS. A press release about that just went out. We have had, since the beginning of the year, Telefonica ramping their 5G core for a portion of their business into AWS. 1 million users are live on it. Their CTO has talked publicly about 4 million subs being on there in the next 18 months. So these are two interesting use cases. Ishwar will talk about a little bit more in detail when we get to that. We also see some early signals with folks like Sunrise and TELUS of them starting to build revenue-generating opportunities using network transformation and using some of the capabilities that GenAI brings to bear. But all of this is, like I said, it is being driven by the fact that GenAI, as our customers think about it, they're finally looking at it and saying, here's a set of investment dollars that I can use to drive the velocity that I want in the business. And the last year has been a lot of experiments around it. And when they actually start to get into production is when they realize that they need to start to really finish the migration and the modernization exercises. So we'll talk about that a little bit. So what does it really take to take this next generation intelligence, build it into everything that a telco does, right? At AWS, we think in terms of flywheels. Now, a flywheel is a mental model. It's a concept. It's like if you take a business, a telco business, pretty much most telco businesses, you can say that the vast majority of their revenue comes from consumers, enterprises using their services, and it's usage-driven. That usage is bound to the network and capabilities you have in the network, which are then used to provide product experiences, right? So that's the flywheel that you think about in the most simplest term. How does the flywheel work? So if you start to see telcos go build out that network and then they build more capabilities in that network, suddenly they're able to do things like provide a product experience that says you get unlimited data. If you do that, customers start to use that unlimited data and watch a lot more video, which then drives further optimization on the network to actually support it. So that's a flywheel, right? And we use these flywheels to really think about when something changes in the ecosystem, how is it going to impact a business? If you think about generative AI in the context of this flywheel then, what you realize very quickly is that we're seeing telcos go after particular use cases. If you think about the engineering effort that's necessary to run a telco business today, a lot of it on the network operations side, a lot of it on the product development side. That's the first place where we're seeing generative AI really start to change that engineering effort, to optimize it. We've seen use cases where 15, 20% benefits are quickly being realized. So then you think about that as a flywheel and say, what could you do with that 15%, 20% more engineering resources? We think that as you automate and get closer to that autonomous network point of view with generative AI, again, you start to say, can that drive down the cost of the network, which feeds back to better networks, which feeds back to better products, right? So this is why generative AI is so interesting for telcos. All of them look at this and then say they can see this impact coming at them. And they think that it's fundamentally going to differentiate and change how they engage with customers. It's going to completely change how they interact with, create, build, run, both IT and network systems. And then over time, I think, build better revenue sources. And wouldn't that be fantastic? Because if you think about telcos, I don't know if you've noticed, but for the last 5, 10 years, it's not been a great journey, right? We've invested a ton of capital, we've invested a bunch of technology, and we haven't actually been able to drive a ton of incremental value and revenue. I think this starts to build for us over time. So if you look at 23 versus 24, in 23, we were here having a lot of conversations around what's Gen AI, what's a model, why should I use a model, that kind of stuff. And then you started to get into POCs. In 24, it got a lot more serious because some of these POCs start to go into production. Now the conversation's around, okay, what data do I need? How do I need to manage my data? How do I really need to start to put the right guardrails around it? If I'm going to use models, if I have to switch it out, if I have to switch a model to another one, what can I do to make sure that I'm not redoing everything, right? And so I'm kind of curious about this audience. How many people here from an operator? Raise your hands, please, okay? How many people with a partner that's helping an operator go through some of this transformation? Awesome. So, why do you think it's been hard to make that pivot into, oh, hey, we've got all this transformation opportunity, Gen AI as a technology is now available. Why has it been so hard to go from what I'm hearing is hundreds of POCs to very few actual production use cases? Anyone have thoughts? You can shout it out. Yeah, there's been lack of scale, there's been lack of resources, there's been lack of infrastructure, but we hear some very consistent themes. We actually ran a survey for about 300 decision makers in the summer this year with TM Forum. And we asked them, like, what are you doing? You've all these use cases, are they actually moving to production? And only 14% of those customers actually said that they have more than 10 use cases in production. Right? Even more scary is the fact that only 50% of them thought after all this work they had a platform that was usable and viable. And only 25% thought that they actually had the talent and the resources to go on this journey. So it has been challenging. And if you think about all the underlying concepts that everyone needs to grasp, it's going to be around how do you build, manage, and run this AI infrastructure? It's not easy. If you thought running and managing normal compute and storage infrastructure was hard, this is way harder. How do you look at all of your data, bring it together in a way that can be consumed, and then actually really properly secure and govern it? That's super hard to do. And everyone's, I think, news feeds over the last year has been blowing up on all the kinds of things that are happening in this space. So decisions that you've made 6 months ago may no longer be relevant. So that ecosystem velocity is also substantial. And then you're having to deal with the reaction to look at something dramatically has changed. How do I go test it? Can I use it in my workflows today? If I make a decision today, am I bound to it tomorrow, right? All of these things are challenges. And this is a key part of where AWS has been able to help some of our customers. If you think about when you're ready to build, and when you're ready to build things securely and responsibly, then the question is, do you have the capabilities that you need? Right? And if you think about that flywheel, and we talked about getting value out of those engineering resources, we're seeing a lot of value being generated at the top of this stack, right? Amazon Q Business, where your teams are able to go in and look at data that they have and use that to drive different workflows, better workflows. For your engineering, software engineering teams, being able to think about enhanced ability to go build out new products and bound to the data that they have in their code base. code bases. When you then have builders that want to build use cases, again, the managed service like Bedrock is giving people the ability to go out and say, okay, I can pick and choose the models that I want that are fit for purpose. I have the guardrails that I need to put in place around it. And once I build it one time and I have different models that are coming into the ecosystem, I can apply the same guardrails all the same way. So it's a very interesting platform play that allows your builders to actually operate at velocity and scale without taking on all of that heavy burden of standing up new infrastructure, running this very power-hungry, GPU-intensive infrastructure that you would typically otherwise have had to run. Finally, we also see for some of the leading-edge operators, folks who are building models, who are training and fine-tuning models, they want managed infrastructure, and that's what SageMaker and that family of products provides them. All of these capabilities, though, one thing that we haven't talked about is cost. And even though over the last year, the cost of training, cost of inference has started to go down, we fundamentally believe that we need to build a next set of capabilities. And that's where like our investment in silicon with Trainium and inferential chipsets is expected to bend that cost curve for us. Because the cheaper you can make this inference, the cheaper you can make that fine-tuning and the training over time, the more use cases you're going to be able to apply these capabilities to. So this is why if you think about how you build in this ecosystem, having capabilities around all three layers of the stack is important, and that's what we're seeing with a number of our customers. Let's have a customer actually talk to you about it. If I can have the video play. Oh, there we go.
Rolling out use cases another. But when we actually try to productionify something, it gets very, very complicated. And so relying on AWS expertise, they have some of the world's best infrastructure. They have a lot of really, really smart people. And so it was a very collaborative effort between AWS, Anthropic, and SKT to actually get this model into production. As I said, Anthropic is very good at modeling. AWS strengths lie in their infrastructure and being able to scale it. And so we worked with AWS and worked well with AWS for a couple of reasons. One is scalability. AWS has huge expertise in that. That being said, we may not have 1 million queries at once, so being able to scale up and scale down was very important to us, and AWS did a fantastic job of offering that and working with us to right-size it for the use case at hand. Aside from that, reliability is also very important. This is a production service. Any downtime has huge financial impact, and so AWS has SLAs or service level agreements in place, making sure that the model is up as often as possible, and if it goes down, having guarantees about when the model will go back, how much they're going to respond to it. And so that was a huge win in our book as well. And the last aspect here is, again, I want to highlight the collaboration. It wasn't just AWS doing this thing in a vacuum. Huge input from SKT, huge input from Anthropic. Anthropic knows their models better than anyone, so they were very helpful. And how do we actually optimize this model? How do we reduce latency? Which are all things we needed to get these use cases to market and surprise and delight our customers. So AWS is fantastic, supporting Bedrock. And so there are 3 key lessons learned here, or takeaways. One is, because we're now faster at responding, our customer experience has improved. Customers are much more satisfied because they're getting responses faster. Korea is a very now, why did that not happen in 5 minutes to go society? And so getting faster responses that are also accurate was super important, so that moved the needle. The other one is response uniformity. Before, every agent had their own style, had sort of how they wanted to spin this. Now with this technology, we can unify the user experience by making sure that responses are as unified as possible. So if user A and B call up the same issue and they get 2 different responses, that's a bad user experience. But again, with this technology, we can now make sure that the responses are the same for each query. So that helped a lot as well. And the third one is for the actual customer service representative satisfaction. Now that they have this technology in place, the ramp up period when we hire someone is much shorter, because again, they have augmented technology to help their job, and their burden is also less because they can tap into this technology and make sure that they're not stressed or not feeling time pressure at work. So it's a huge win on all 3 of these fronts, and we're very happy to have rolled out this technology.
So that was Eric at SK Telecom talking about how, as they've spent the last year really prepping for building and working with both Anthropic and us, the amount of effort it took to get a TelCloud LLM built, fine-tuned, launched. There's a fair bit of technical detail around it. There's actually a session that we have. I'll call out the session details, or Ishwar will at the end of this, that you can actually go through. But the thing that should resonate is it is so worth going through this effort. If you heard about Eric talk about the 3 things that were beneficial for them, right? He talked about the fact that they're able to get better answers faster. They're able to go get uniform answers in spite of the fact that you're getting different questions. And then they're able to take their customer support engineers, customer support staff, and onboard them faster. And they're able to give them the ability to react in a much better fashion, reducing stress levels there. All 3 are super valuable for most telcos that I'm talking to. And so it is worth it. So then why is it so hard to do? And it's hard to do because this is what a typical well-built that we know of today, unless you know better over time, a platform starts to look like, right? You have, for your enterprise, a number of organizations that are trying to take use cases and put them through this process. You want to have a landing zone where they come in, they start to take these capabilities. You want to give them the ability to onboard easily. You want to give them the ability to go connect into a bunch of different data sources in a uniform fashion. You want the ability to then set guardrails to get safe responses and then pick the model that you want. And over time, as you iterate on all of these capabilities, then you start to connect into the agents that we're starting to see deployed. A platform of this nature is what your teams are going to need to build. And if your platform teams are not thinking this way and they're just thinking about single use cases, I send a request to an API, I come back. I think longer term, you're not going to be able to scale this in your business. So again, tough. It's easy to kind of think about the ChatGPT interface as the way you would interact with things, but underlying that, in a generative AI platform of this nature, where you want to be able to use enterprise use cases and build in the workflows and the capabilities, you have to think end-to-end for the platform. When you build this at scale, for some of our more forward-leaning customers, there's, like I said, they're seeing the value, right? British Telecom has talked about when they deployed Q Developer for their 1,200 engineers, they've started to see 15% improvement. So it's proving out our thesis that you can actually get better. They're seeing 35% and increasing acceptance of the recommendations from Q. Like the platform that I showed, they've built out and they've come back to that realization that you need that kind of a platform where you can take a Gen AI gateway that allows you to build all the same guardrails, pick models from multiple providers, and then consume it as part of a Gen AI gateway. And they have talked publicly about how they've implemented it. It's allowed them to go in and quickly iterate to find the right models for the right use cases. It's not just happening with our operator customers. We're also seeing this with some of our partners. Amdocs has talked publicly about taking a platform like Bedrock and making it a part of their Amaze platform offering. And what it is allowing them to do is, again, provide their end operator users the ability to go pick the right models for the right use case. So lots of interesting stuff happening here, and I think it's just getting started. If you think back to that flywheel we talked about, right? We are seeing now that intelligence from the data in the middle of the flywheel actually building insights for us, and it's happening at scale. But insights don't really do anything for your business until you get to actions. And so then the question is how do you drive impact and action? And this is where the prerequisite that we're seeing is modernizing your entire set of ecosystems at scale. Regardless of whether it's your IT systems that need to interact with your digital marketplace, your flows, or your billing systems, where if you can just get that bill explainer right and you can deflect a bunch of different calls, if you can get into a modern call center that actually can take some of this insight and intelligence and provide it as guidance to your call center reps. We're seeing early use cases now in the network operations domain where you can take all of that data coming together and then start to make decisions. I haven't seen anybody automate a lot of decisions and action and reaction to it, but we will get there, right? You can start to see that first step to saying, okay, we can drive autonomous networks. We're able to drive to action when we have modern systems. And that is a key enabler and a key prerequisite for any operator that really wants to end up using this technology at scale. We do see challenges, there's no question about it, right? So the key challenges that we're seeing at this point are, in some cases, we have some vendor selections in telcos that are pretty normal, where moving them to the cloud has been a little bit harder. It's more expensive than it should be. And then we're starting to see a lot more conversations around data sovereignty, especially as regulatory environments change. What we're doing is we've spent the last year really figuring out some of the spaces where we can help. As most telcos around the globe build large VMware infrastructure, we've been spending time with them trying to help them figure out what are the paths for modernization. So the traditional transition it over to EC2 instances, if you're going to containerize it into EKS and modern container and Kubernetes management systems, you can take them and for some particular use cases, transition them into functions that run on Lambda. But we also know there are a set of use cases where you cannot do it directly in the confines of the public cloud. You have to do it on-prem in your environments. And so taking these models and applying it to Outpost infrastructure sitting in your data centers is the path we've provided. Some customers have come back to us and said, well, that's great, but I also want to explore other partner options. So we've built paths with Nutanix and with Red Hat OpenShift. Recently, as of like 2 days ago, I'm pretty excited that we announced our new Elastic VMware service. So if you are an operator that wants to bring your VMware footprint to AWS, now we have an option for you to bring that cloud foundation, run it within the confines of your VPC, connect it back into everything else you do with AWS without a lot of transformation, take those workloads and move them over, right? So I think with the VMware workloads, we're getting there to a point where you can modernize this at scale and effectively. We're seeing similar things with Oracle. Like we've always had paths for you to run Oracle databases. A lot of your systems, all of your ISV systems that are dependent on Oracle as a database, we've been able to run those within RDS. But if you have really large engineered systems, which a lot of telcos do, and you have it running on rack, we've not had a very good path. And so recently we announced a new collaboration with Oracle, where the Oracle database at AWS is a model where Oracle infrastructure sits in our data centers. You can run your Oracle workloads on these rack or engineered systems infrastructure closely connected in with the rest of your AWS footprint. It allows you to deploy these databases without a lot of transitions and changes. So VMware, Oracle, and I think we'll go back in and knock down all the other blockers that prevent you from moving and modernizing at scale. We've talked a little bit about digital sovereignty and the fact that as regulatory regimes change, our operators are getting a little bit more concerned that they will need to choose between the full power of what AWS provides and what they want in a large public cloud type environment. It's a full-featured environment that they want. And so we firmly believe that customers should not have to choose between these two things. And as you've seen in Europe, we've deployed an European sovereign cloud that is all of the public cloud capabilities deployed within the boundaries of Germany with EU nationals operating that environment. So over time, we will commit and deliver more of these capabilities in each of the geos where the regulatory requirements demand that we need to do that. Overall, though, I think it is totally worth it. If you think about a modernized customer that's actually seeing value out of it, let's hear a little bit from UMO2 UK, and then we'll have Ishwar come up to talk about the network transformation piece. Yeah.
Yeah, so I'm Alan Stott. I'm the Director of Customer Contact for Virgin Media O2. Virgin Media O2 is a UK-based telecommunications company with around 6 million fixed-line customers and 40 million mobile connections. We have 44 locations globally with just over 10,500 agents. So our vision was one of convergence. We'd converge the brands. Virgin Media and O2 had come together. We wanted to converge the service experience to enable a continuous conversation, regardless of where the customer came from and regardless of the touch point that the customer came to. What AWS provided for us was simplicity. Simplicity of integration, simplicity of our very complicated technical stacks, and simplicity to allow, through data and insight, a continuous conversation. What we're seeing in the migrations that we've already done is improved customer satisfaction. We're seeing reduced handoffs, which was one of our key ambitions. We're seeing greater agent empowerment through the data that we're providing for them. We're seeing greater, better customer outcomes, a result of that simplified operating model and greater insight to the customers. AWS became part of our team, understood our customer issues, understood our business challenges, and worked with us to collectively solve for those challenges. So the key learnings for us in integrating Amazon Connect was around understanding that as an organization, we had to be a partnership. So Accenture were obviously very established with Amazon, with AWS and the Connect product. They understood from their experience how we could exploit that product to deliver different and better customer outcomes in the long term. It just accelerated our learning. We're excited about some additional components that we see for launch later in this year. For instance, in the AI and generative AI space, we know there's support coming along in quality management components. The partnership with Amazon means that they are with us every step of the way to help unlock different customer solutions, be very bold about how we embrace that technology, and again, deliver very, very different outcomes for our business.
Isn't that fantastic? Every operator that's been on these journeys with us, they end up excited about the value that they can bring to their customers. And we feel like this is where AWS excels. We can go work backwards from what the customer wants to build and deliver. In this use case, the Connect deployment is now allowing them to go in and take capabilities that GenAI is going to expose and get them to move faster. I think longer term, this set of innovation really sets the industry up, drives more innovation. We get all of that engineering capability that we have back into the business to go out and build better products. And then I'd love to see us go out and build these products that customers really want and drive a little bit of growth in the industry. That would be a fantastic outcome out of all of this. And to talk about how the network is transforming with AWS, to do all of that, Ishwar, I'll have you come up.
Thank you, Chivas. My name is Ishwar Parulkar. I'm the Chief Technologist for the Telecom vertical at AWS. Let's move on to the core asset of the telcos. The network is the core asset. And we've been working for the last few years in taking them on this journey of transforming their networks to become more cloud native. What does cloud native mean? Cloud native means lowering the total cost of ownership by multi-tenancy and elasticity. It means becoming more agile, using operational models that the cloud has been doing for the last 17 years, which is 24/7 updates, continuous integration, continuous delivery of software, automatic upgrades and patches, and so on. And along with that, bringing in the security resiliency that comes with the cloud. That's what we mean by cloud native, and we've been on this journey with telcos for a few years now. And what we see is a roadmap of workloads coming onto the cloud progressively. And there's 3 dimensions to what determines the sequence of how we see these workloads, network workloads or network functions as workloads on the cloud maturing onto AWS. The first dimension is complexity, how complex they are, what are the performance requirements. Some of these are very stringent. They have very high bandwidth packet processing requirements. Some of them are not so much. The type of features that are required are very unique to some of these workloads, and so on. And the cloud has continuously evolved to handle more and more types of workloads. And what we've been doing over the past few years is enhancing the cloud and our services, EC2, VPC, load balancers, and so on, to be able to run these network functions. At the same time, we've been working with ISVs that build these software functions to become more cloud native. So the first dimension is complexity. The second one is latency sensitivity. Some of these are more latency sensitive, some of them are not, and that determines where you want to place them in the cloud edge continuum. So we have the regions, we have local zones, we have deployments for the far edge, and it's a matter of where they fit in. And that plays a role in how early telcos or how late telcos are in adopting this. And the third one is whether they need to be centralized or distributed. And again, this plays a role on where they get placed. Can they use the regions, or do they have to rely on the edge cloud to function and to operate in an end-to-end network? So as you can see, the workloads that are on the low side or the centralized side of these dimensions are the first ones to be mature and get adopted, and we are progressing across these dimensions on other workloads as well. So let's go a little deeper into some of these workloads. So OSS, BSS, Operation Support Systems and Business Support Systems. This is by far the most mature category of workloads. And again, this is something we started working on probably six years ago. These are not complex from a performance perspective or a feature perspective. They are like IT workloads. They can be run in a centralized manner, and they're not latency sensitive except for maybe one or two functions in the OSs. So they naturally are more mature. We have several partners who have deployed their OSS BSS stacks on AWS. They comprise many native services from AWS. But the most interesting fact here is not only do they run on AWS now, they're moving to SaaS models. So partners are offering these in software as a service models with a subscription or pay-as-you-go models. So that's a big leap in terms of how telcos are now using this workload. And this is by far the most mature, moving to really more advanced commercial and deployment models like SaaS. Now what we're seeing is IMS and 5G core is also reaching a level of maturity with quite a few live national networks. So we started this journey about 4 years ago with Boost Mobile. This was a greenfield operator. They did not have data centers. They did not have fiber on the ground for backhaul. So in a way, it was an exercise which was grounds up, right? From having nothing to really building a fully productized national level network in a cloud native manner. So we launched this in 2021, and in 2023, we reached Boost Mobile was able to reach 70% national coverage. So this is quite an accomplishment considering that this was built in a completely modern cloud native manner. But this was greenfield, right? What about brownfield? And earlier this year, we worked with Telefonica, and Telefonica launched a 5G SA core in the Frankfurt region, on AWS Frankfurt region. Now, what was different about this was a brownfield operator. They had data centers. They had fiber in the ground. They had internet peering points that were already established. So we had to figure out how could we fit our cloud model into these constraints. And we were able to do that successfully, moving 1 million subscribers from their existing network to this cloud native core running in the Frankfurt region. Today we are announcing Comcast, a US brownfield operator that is moving their on-prem components of their on-prem core onto AWS, 2 regions. They're using 2 regions and serving multiple markets. Now, this one was another step in the sense that this did not require any engineering involvement or deep ISV partnership to get this network up and running, and it took a matter of weeks to really deploy it. So starting from greenfield networks, which involved a lot of engineering effort between operators and us and the ISV, a 3-party engineering involvement to really figure out what features are needed, how to operate the network, to a state now where we can even deploy in brownfield networks with constraints, with existing infrastructure, and in a ready-to-deploy manner in a matter of weeks. So this is quite a journey in terms of the maturity of the 5G core. In the evolution of the cloud over 17 years, we've always seen points in time where we hit a new set of workloads where we have to enhance the cloud to really handle them. And this is a case now where something like the packet core is what we consider a mature workload or running on AWS. Let's hear more from Malik Rao, who's the CTIO of Telefonica, and how they approached using AWS to migrate this 1 million subscribers and the benefits they derived.
My name is Malik Rao, Chief Technology and Information Officer for Telefonica in Germany. The vision for me is telecom is good in adopting, but we're not good at disrupting ourselves. And that is something cloud as a technology was really attractive for us, which disrupts ourselves in terms of technology, in terms of operating model, in terms of culture. So these are the 3 essential elements for me when we started off this whole journey of cloud at the core of telecom. We've been working with AWS to bring core functions of telecom onto public cloud. It took, of course, 3 years for us to go there, bringing the services quicker to the market, innovating on services. That was the primary reason for us. And of course, working with AWS and in this case with Nokia on the packet core software for the 5G standalone. The outcome for the customer, what we were trying to drive with this solution is how can you scale quickly? How can you deploy software in-service upgrades and also innovate the services? When we've been connecting the, say, core network with the internet, however, if you want to go with 5G standalone, 5G advanced, low latency applications, and that's where we want to be quickly to the time to the market. What I really like working with AWS is it has agility at the core of it. Because the journey when we started off, the public cloud was not ready for taking the telecom applications. And then the agility of AWS was really impressive. And that's where I felt very confident that I can take the core of my systems into public cloud. It's agility, it's nimbleness, and also learning. And it took 3 years for both of us to really learn. And today we have 1 million customers working live in the Frankfurt region. I get more and more confidence that I can move millions of customers onto this platform, what we have created last 3.5 years.
So as you can see, quite a big leap in terms of maturity of the cloud, the core workload on AWS. But it's not just about running these network functions or parts of the network in a normal operating manner. What the cloud has been able to do, especially in the 5G core space, is really addressing use cases and scenarios that wouldn't be possible with traditional networks or the way networks were built traditionally. And let me give you a few examples. So one is a multi-tenant API-driven MVNO. The fact that you can spin a core very quickly where you have an existing brand infrastructure from an operator and use APIs to quickly spin up services just has changed the game in terms of how MVNOs can create networks, deploy networks, and offer services to their customers. So last year, we had Mobi, MVNO wireless carrier from Hawaii, use Working Group 2, which is now part of Cisco, their multi-tenant core, running on AWS. And again, in a matter of days to weeks, they were able to spin an MVNO with a radio network from T-Mobile and start offering customized services to customers. Just a few days ago, Oxio, which is another MVNO, announced, again, being able to use components of the core running on AWS to spin an MVNO using AT&T as their RAN provider. So as you can see, this really opens up a very different way of building MVNO type of networks because you can quickly deploy a core. You don't have to wait to provision hardware. You can be multi-tenanted, you can scale up, scale down, and really a fantastic use case for using the cloud to run network functions. The second one is high availability and disaster recovery, using a copy in the cloud. So redundant systems obviously need copies, and one of the ways you can do this is have an on-prem copy of your network components, and then there's on-prem instance of the network components, and then a copy of that in the cloud. And you can have these running redundantly in a high availability mode, or in a disaster recovery mode, you could burst into the cloud. So you're just running on-prem with maybe a little seed of traffic in the cloud, and when there's a potential disaster which brings down your on-prem core, you can burst that traffic into the cloud. So these are techniques that wouldn't be possible with traditional networks because you would have to provision a lot of hardware to take care of this. With the elasticity of the cloud and the fact that you can just spin up when you need these things and spin them down when you don't need them, this creates a very, very cost-effective, cost-efficient way of applying these architectural scenarios. The third one is around virtual roaming gateway. These are roaming gateways that help subscribers roam between two operators. And once they're virtualized, you can deploy them as a software appliance. And once you go cloud native, you can use edge locations in the cloud to deploy them in a most optimal location and spin them up dynamically when needed and move them around if needed. So this helps you optimize latency between the operators. It also gives you resiliency because it's inherently resilient, the infrastructure. And more importantly, it's dynamic. So you can move these roaming gateways depending upon the architecture, subscriber traffic, and so forth. So again, this is a use case that wouldn't be possible with traditional approaches where you would have to provision hardware and fix the roaming gateway in a certain location. So really, not only running production networks, but really an expansion of use cases because of the cloud. And this one, yeah. So these are some codes from the TELUS, which implemented the roaming gateway, talking about how it helped them be resilient and dynamic, and also Oxio, which was the MVNO that I talked about earlier, which has leveraged AWS to really deploy a very flexible network very quickly. Let's move on to RAN, which is, I think, the next frontier. Now, this is the most complex of workloads, and understandably so because of the lower layers of the stack. The L1, L2 layers are very performance demanding. There's beamforming, there's a lot of matrix computations, which still require accelerators, can be done on general purpose computing silicon like x86 silicon. And so that's one of the reasons that these are one of the latter ones to start interacting with the cloud. They're also very distributed, so these have to be obviously at the very far edge. So that's the other dimension I was talking about in terms of complexity, in terms of adoption sequence. What we've tried to do here is really look at this area from the perspective of where can the cloud differentiate. And we see few areas where we think we can differentiate in this space. One is obviously with the machine learning. There's a lot of work happening in the AI ML space for the RAN in terms of optimizing the RAN as well as building XApps, RApps in the ORAN architecture that will be ML-based. Quite a few of them will be ML-based. But we're looking at ARM as a foundational block to build infrastructure that will help host RAN workloads. And there's three benefits to that. One is price performance. As I mentioned earlier, these are very demanding workloads. The L1, L2 layers of the stack are extremely performance demanding using accelerators. But Graviton, which is our ARM-based family, has one of the best price performances compared to other architectures. So that's one of the benefits you get here. The second one is power efficiency. As you're well aware, ARM is one of the most power efficient architectures. And 70 to 75% of the power is consumed in the RAN. Power in the network is consumed in the RAN. So what we wanted to do is deliver a significant energy savings by changing the underlying architecture for the RAN part of the network. Lastly, giving customers flexibility and choice. This is one of our key tenets in the company, is to give customers choice. And we wanted to create choice of silicon for the vendors to offer some of these RAN stack components. So this is kind of what we are working on. I think this is the year, 2025 will be the year of the RAN, where operators will go very deep into understanding how the RAN can be deployed. Virtual RAN and Open RAN can be deployed and deriving the benefits of that, leveraging the cloud as well in the whole process. So Nokia has experimented with the Graviton processor and seen significant performance gains because it does efficient layer 2 processing, but also it's compatible with their layer 1 accelerator, which is ARM-based. Docomo is another operator that selected AWS Graviton for the 5G core because primarily of the power savings, and Amazon EKS-A for their vRAN deployment. Now, EKS is our managed Kubernetes service. It's called Elastic Kubernetes Service. That's what EKS stands for. EKS-A is the EKS Anywhere version of it, which allows you to run EKS components in the same configuration on third-party hardware. So Docomo is doing that, and let's hear from Okagawa-san more about what Docomo is doing here.
My name is Takatoshi Okagawa, Senior Vice President of NTT Docomo. and I'm in charge of the NTT Docomo R&D division. AWS is one of the most important strategic partners for NTT Docomo. Our collaboration is the most symbolized by the recent 5G core network on AWS and also VLAN project, as Docomo plans the nationwide deployment of VLAN starting in 2025. As a key component of VLAN, we have selected EKS Anywhere, provided by AWS as a virtualization platform, together with NEC VLAN software, Qualcomm hardware accelerator, and also HP hardware platform. With this VLAN architecture, we will be able to deploy new features with flexibility and shorter time to market, and also leverage COTS hardware and hardware accelerator, which are becoming more powerful and energy efficient for the broader market outside telecommunications. In addition, with EKS function, we can automate network management and operation, reducing OPEX and increasing network service availability. And we also expect the potential of the AWS ecosystem for the value creation. The benefits of its many service applications running on EKS and the engineers familiar with EKS tools and environments. For example, so we can leverage the ecosystem to add value to our network by running applications like a JI on VLAN platform, sharing the same computing resources. So finally, we are looking forward to further exciting collaboration and good outcome between AWS and NTT Docomo.
So it's really been great to see this journey of telcos in adopting the cloud to actually run networks, which is their core asset. And I'm very excited to see what this next year will bring in the radio access network space, which happens to be the most challenging. But also, interestingly, one of the places where cloud can play a big role, especially because of what AI ML can do in that part of the network. There's also work we are doing on autonomous networks and using Gen AI in networks, right from building, deploying to operating. And there's a session on this, which is why I've not covered it in here, but I would highly encourage you to go to that session. So there's, again, Gen AI and AI ML in general being infused into networks, and we are working closely with operators in seeing how we can help them transform that space as well. Going back to the flywheel, as you can see, becoming more cloud native in the way you build and operate networks leads to obviously cost efficiency, cost gains, but a better product experience as you can develop new services in a more agile manner, leading to more usage, again, in turn, and accelerating the flywheel. Let's move on to new sources of revenue and how telcos can really build their growth engine even further. So there's a few ways there are quite a few strategies that telcos are looking at, and we are helping them with those. But it's basically trying to get past the connectivity layer. So going really beyond just connective services to other services and offerings. And here they're leveraging working with the cloud infrastructure, including the edge continuum that we have, and the services on top, to really build another layer of managed services, solutions, and new product offerings. But it's in combination with the cloud that they can really start opening the floodgates of some of these new product experiences that they can build. And the way we work on these is, kind of come up with a concept, do the proof of concept, and then really productize with AWS services. And we've gotten a lot of traction in some of these areas in the past couple of years. So I'm going to talk about two strategies. One is really getting into adjacent markets or adjacent areas of business, and the other one is really using network assets which are beyond just connectivity. So let's talk about the first, which is looking at adjacencies to telco's core businesses. So one of them is smart home that we've looked at. If you look at the current smart home experience, users today have multiple devices in their homes. Each one of them have multiple apps. Think of Alexa, which are our own. There's Google Nest. There's security cameras from many different vendors. You have different apps, different devices, different apps, different platforms. They don't talk to each other. So it's a very, and just setting them up, onboarding is complex. The technical support and guidance is not there in a very user-friendly manner. So it's a very fragmented experience. Secondly, you have to set individual routines. There is a lack of AI, or the potential of AI has not been fully tapped into in really helping customers manage these multiple devices and create routines. Even today, each device is kind of configured manually. So what we are doing here is really, and this is something that TELUS, which is one of our customers, found in polling their users, that 37% of the users had problems, reported problems of complexity. That's a pretty high number for something that should be really simple. It's very consumer-facing, should be very simple. So this is one area where we worked with an operator like TELUS to really solve this problem for them using cloud services. So one of the first things we did was build IoT services to ease the process of onboarding devices from different third-party providers. So really a homogenized experience for onboarding, a plug-and-play homogenized experience for onboarding devices from multiple ecosystems. And also an IoT service to help integrate this front end of onboarding to back-end telco systems, middleware, and the back-end systems of billing, charging, and other things. So a set of services, IoT services that we have built in the cloud to help telcos offer smart home capabilities, either by building apps on top of this or offering this platform to developers to build apps. The other area that we are working on with telcos is using AI, in particular Gen AI, looking at all of the data they have from these devices and continuous learning of user behavior in terms of how they use these devices in their home, to then use Gen AI to recommend routines and help configure these devices in a more automatic manner. So essentially, IoT services coupled with some of the other technology that we have in AI ML to really provide a smooth, frictionless experience for customers, as well as recommendations to manage this complexity of devices in the smart home. So TELUS is, as I said, using this in September of this year, earlier 2 months ago, 3 months ago, they launched a smart home app which helps users, consumers, optimize their energy usage in their home and really gain savings from the power companies. So that's just one example, but this just opens up a potential for a plethora of applications, smart home applications that can be written on top. Now, this is one really good example of an adjacency that TELUS leveraged in the smart home area and kind of grow their top line. A second example I wanted to go over was the SMB cloud solutions landscape. These are small, medium businesses. Now, small, medium businesses deal with legacy applications. They have a big challenge transforming their legacy applications, understanding how to improve the performance, and in general, do not have awareness or expertise required to modernize and migrate to the cloud. And again, here we see large-scale SMBs that are more focused on security, governance, and improving the performance of applications. And then there are smaller SMBs that really want point solutions, like HR and payroll, or productization systems, things like that. They don't have a lot of budget for IT and migration of these applications. So we see this bifurcation of small and large SMB cloud providers. It's a very fragmented market, and it's very difficult to have one channel or one way of helping these SMBs solve their problem of modernizing and migrating to the cloud. But one thing they have in common is that all of them have a connectivity provider from whom they get mobile and connectivity services. So that is an opportunity for telcos to really help SMBs offer SMBs not only connectivity but also cloud solutions in a combined manner. So what we're seeing telcos do here is really partner with us and bring our ISV ecosystem. We have a very large partner ecosystem on AWS Marketplace and other channels. So they are combining AWS services with our partner ecosystem to build packaged products that combine what problems that the SMBs are trying to solve with the connectivity offerings they have in a very homogeneous packaged manner. Secondly, they're using GenAI, infusing GenAI and other AI/ML technologies to really learn from usage and consumption of these services to further improve, refine services and figure out new services and features to offer. So this is, again, a very lucrative dimension for telcos to explore in terms of increasing their top line. SMBs rely on telcos for connectivity. Telcos can then leverage that relationship that they already have working with AWS to offer combined cloud and connectivity solutions. And Sunrise is an example. Sunrise is an operator in Switzerland that has done this extensively, and we're seeing more operators starting to leverage this model. So this was about growing the top line by getting into adjacent markets. A couple of examples. There's obviously more potential here. The other angle we see here, other strategy we see here telcos adopting is using network assets beyond just connectivity. So if you look at a network, there's a lot of information in the network. There's a lot of data in the network. There's information such as location of devices, status of the devices, what applications users are running, whether a SIM has been swapped, being able to verify a mobile number with a user. A lot of capabilities in the network that have been untapped to a large extent. What telcos are looking at is to monetize these assets by offering these through APIs that any developer can use and integrate into their application. This has really accelerated in the last couple of years, and there's there are different approaches here to building these APIs. There's obviously the CPaaS ecosystem, communication platform as a service providers, who have been doing this for the past few years successfully. These are higher level of APIs, but we're seeing more of the network layer of APIs as well now coming into the picture, and quite a few different bodies working on these APIs. Now, this is very natural to us as the cloud. Cloud is a lot of innovation, a lot of technology built over 17 years, over 250 services now. But everything that we develop is offered and consumed through APIs, thousands of APIs. So it's a very natural thing for us to see the network being offered through APIs to developers. What this can do is firstly change how you offer the network, how the network is consumed by users. It's traditionally been time, minutes, and then data slabs now, but there's much more flexibility and much more opportunity here to offer the network in very, very different consumption models. And the parallel here is our compute platform, which is started as just renting servers to now having a lot of different models, consumption models around compute. So flexible network consumption model and network enhanced applications. And these are applications that can be enhanced with information from the network or allowing programmability of the network. So for example, fraud detection using information such as whether a SIM has been swapped in a phone, or verifying the mobile number with the user and so forth. So there's an opportunity here to build applications which are enhanced with this information, and in turn use a lot of the assets that can be monetized by the operators. What we're doing here is bringing our wealth of AWS services, over 250 services actually, and combining them with these APIs to offer a seamless developer experience. So the idea here is, you can't just build applications with network APIs. You need compute, you need storage, you need databases. We have them. We have developers who've been programming to these for several years. So what we're doing is really providing a seamless developer experience by combining these with the network APIs. So this becomes another strategic arc that the telcos can rely on to monetize their assets. It's to be seen when and how this will be monetized, but a lot of excitement in this space right now. So I would encourage everybody to go to some of the sessions we have. We have a lot of sessions on tap at this reInvent. Some of the ones I would highlight are the generative AI-powered graph for network digital twin. This is the network automation part I mentioned, where GenAI is playing a big role in the network transformation. Then there's also the SK Telecom's TeleCloud, very interesting use case for really building and tuning foundation models on AWS for telco-specific use cases. And lastly, but not least, the telecom demos. I mean, the presentations are great. You learn a lot from that, but nothing like seeing what we built in action. We are a company we call ourselves a company of builders, so do go and see the demos as well. Thank you for coming in and spending this hour with us, and thank you for listening. If you have any questions, we're available on the site to answer those questions. Thanks again.